So hello everyone, we are Team Explorers, and today we are here to present our final project on WSN, which is on obstacle avoidance car. So let us have a look at our team members. First member is Annaya Sharma, then Gunal Gupta, Servo Sharma, myself as Taunk, Ishita Agarwal, and Lavanya Bansod. So let us have a look at our table of contents. So first we will have a look at introduction, and then the problem statement, then components used, and then the methodology, and then algorithm. After that, we will have a look on working model, and then conclusion, and then application. So, in the evolving landscape of robotics, the development of intelligent vehicles capable of navigating complex environments is a significant area of exploration. This presentation delves into the design and implementation of an optical avoidance car, a project centered around the integration of key components such as Arduino Uno, ultrasonic sensors, servo motors, and motor driver sheets. The motivation of this idea arises from the critical need for efficient optical avoidance systems in robotics, particularly in scenarios where autonomous navigation is of high significance.
So coming to the problem statement, the objective of this project is to design and implement an obstacle avoidance car using Arduino. The car should be able to navigate through its environment autonomously, detecting obstacles using an ultrasonic sensor and avoiding collisions by adjusting its path. Next. The components used in our project are Arduino, which is the brain of this project, responsible for processing sensor data and controlling motors. Next, we have is motor driver shield, which is used to control the movement of the car vehicles. TT gear motors, which drive the wheels for locomotion. Servo motor, which is used for steering the car. Ultrasonic sensor, which detects obstacles and measures their distance. 18650 Leon batteries, which are a power source for the motors and Arduino. 18650 battery holder, which is used to securely hold and connect the batteries. Male and female jumper wires for interconnecting components on the breadboard. Acrylic sheet, which serves as the chassis for the car. And last is DC motor switch, which enables easy on-off control for the entire system.
So next we have the working methodology. First, the component we have used is ultrasonic sensor. So the ultrasonic sensor serves as the car's eyes, which continuously emits ultrasonic waves, and it measures the time taken for them to bounce back from the obstacle. Next, we have the Arduino Uno, which processes the distance data received from the ultrasonic sensor, making decisions on the car's movement. So basically, it's the brain of the car, which calculates the. Next, we have the motor driver shield for wheel control. The motor driver shield translates the Arduino's commands into precise movements of the wheels. Depending on the obstacle's locations, the motor driver shields adjust the speed and direction of the wheels to navigate around the obstacle. So next we have the power management with lithium-ion batteries. So this is our lithium-ion batteries. The 1800 650 lithium-ion batteries provide the necessary power for both the Arduino and the motors. The batteries are connected using a secure 1800 650 battery holder, ensuring a stable power supply for the entire system.
The next we have chassis and physical structure. The car structure is built on an acrylic sheet, providing a sturdy and lightweight chassis. The arrangement of components on chassis is designed for optimal weight distribution and balance. Next, we have user control with DC power switch. The inclusion of the DC power switch allows the user to easily turn the entire system on or off, providing convenient control. Other is servo motor for steering adjustment. The servo motor is responsible for steering the car, enabling it to change direction when needed. By adjusting the angle of servo motor, the car can make precise turns to avoid obstacles in its path. Autonomous decision making algorithm. The Arduino code implements an algorithm that continuously checks the ultrasonic sensor data. If an obstacle is detected within a specified range, the algorithm triggers a series of actions, moving backward, steering away from the obstacle and then resuming forward motion.
So continuing the algorithm, first we set up our Arduino pins and servo motor and our whole ultrasonic sensor and implement them with their respective libraries. Then we feed them a program. So let's conclude this using an example. Suppose first the transmitter sends an ultrasonic signal burst at 40 kilohertz range around. The signals gets reflected back when an object comes in front of the sensor and it is received by the receiver. So the same thing would be happen in the main loop, and the ultrasonic sensor generates high frequency sound waves and evaluates the echo that reaches back to the receiver. So by using this technique, the ultrasonic waves calculate the distance between the car and the reflected object continuously. So as soon as the obstacle detection is been made, the car changes its direction by making an autonomous decision. It can measure the distance between itself and surrounding objects in real time, and the same can be feed into the program using the repetitive loop. So let's see the working model of it. Harsh, you can present the video. जल्दी दिखाओ.
आगे तो बनने दो उसको.
एक कर क्या कर रहा है? नहीं उधर हाथ लगा उसी टाइम. हाँ बढ़िया.
अच्छा तेरे तेरी शाळा आहेत ना का? उसका ड्रिफ्टिंग अच्छा नहीं है बीच का.
ये बढ़िया बढ़िया. अब जाएगी.
बढ़िया स्ट्रेट हो गई.
ये वाली लेना.
चल चल बंद करते हैं. ले 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 रुक जा.
बढ़िया है.
राइट में आएगा उसके थिंकिंग के हिसाब से यार.
एक भाई तो
चला गया.
इतना तो एडिट हो जाएगा.
चलो भाई चलो.
नॉइस
ए भाई मेरी बॉटल.
नहीं बच गए सही सही टाइम पे बैक हो गया. निकलेगा.
ये
स्टार्ट.
So thank you Harsh for this presentation of our prototype. Let's move towards the application.
So application of this model is automated lawn mower, smart room cleaner. Obstacle avoiding robots can be used in almost all mobile robot navigation systems. They can also be used in dangerous environments where human penetration could be fatal. Unmanned vehicle driving, mining vehicle that uses obstacle detection. Uh, so conclusion is the obstacle avoider car successfully navigates through its environment, avoiding obstacle in this path. The car responds to the input from the ultrasonic sensor and adjusts its directions accordingly. Thank you.